right, so we're going to be going over what we've done so far in NumPy, right? As I said, we've looked at several concepts in NumPy. We've actually covered a lot of ground in NumPy, right? So you can see here that these are the objectives, right? These are the learning objectives. These are the things that you need to know after we are done with this particular part, right, which is NumPy. So you should understand the fundamentals of NumPy and its advantages over standard Python lists. So by now you should already know the advantages that NumPy has over Python, standard Python list. You should be able to create, manipulate, and perform basic operations on NumPy arrays. So at the end of this class, you should be able to create, manipulate, and perform basic operations on NumPy arrays, which is the NumPy array is the data type in NumPy. You should also be able to apply NumPy for various numerical computing tasks. All right, we are going to be extending this to the other libraries we'll be looking at. So moving forward, you get to understand this last part well, but these two parts here, by the end of this class, you should be able to do that. That is a test of he is going to test your knowledge, and basically he's going to test you on what we've done so far. If you can't do these two things, then you need to go back to the videos and just look at those things that you've missed, right? So I'm just going to ask a very simple question now. I said here you should be able to understand the fundamentals of NumPy and its advantages over standard Python. So can someone just tell me an advantage that NumPy has over standard Python list? That NumPy array has over standard Python list. I think I've mentioned this several times over the course of the classes that we've had on NumPy. Yeah, it's faster. Why is it faster? Yes, it is faster than NumPy Python list. Why is it faster? That is exactly what I want to hear. Thank you, Nkechika Collins. Exactly, vectorization. I explained this yesterday, that NumPy uses vectorization in implementing or performing its operation. You understand? So that is, the vectorization is what makes NumPy, working with NumPy, faster than working with normal Python lists. You understand? So please keep that at the back of your mind. What makes NumPy faster is vectorization, right? Parallel processing. So in case you are asked, or in case you come across anything of that sort, just understand that vectorization is what makes NumPy, working with NumPy, very, very fast and more efficient than a standard Python. So I just wanted to just let you understand that. So we'll be moving ahead to today's what we have for today. All right, so we've looked at operations on NumPy arrays, looked at element-wise operation, array broadcasting, vectorization, right? I explained all this in yesterday's class, right? So today we're going to be looking at array manipulation. All right, so how can we manipulate our array? So we've seen how we can perform operations on NumPy array. Now we're going to look at how we can manipulate our array. Manipulation basically means changing the structure, changing the shape, and just changing the structure and the shape of your array. That is basically what manipulation is, and we can actually do that in NumPy. NumPy gives us that flexibility, and it has a lot of functions and methods that we can use to perform this particular task of manipulation. All right, so let's just quickly go through what we have here and then move on to illustrate it in code. So NumPy manipulation is crucial. It's a crucial aspect of working with NumPy arrays, right? It allows you to reshape, transpose, flatten, join, and split arrays to suit your data processing needs, right? So I'm going to go over that again. Manipulation basically involves reshaping, transposing, flattening, joining or concatenating, and splitting arrays. So these are the things that you would be doing when manipulating your array, right? So you need to understand, you need to know this, even if you don't really use everything, right? You just have to know that you can actually perform this manipulation on NumPy arrays. Someone was asking yesterday of the use cases of this NumPy arrays. NumPy is a fundamental library in Python, on top of which we have other libraries that are built. So if we are able to finish your time today, I'll introduce us to Pandas. Pandas is a library for data analysis in Python. So Pandas is built on top of NumPy, right? So all these things you are learning now, they are the building block of other libraries you'll be learning as we move forward. So understanding NumPy is crucial in understanding all those libraries, as well as when we get to, or when you start doing machine learning, right? Especially those of us that want to advance and specialize in machine learning, understanding NumPy is very, very key, right? Because you'll be working with a lot of arrays, right? And you need to understand array dimension. You need to understand all these things. So having this foundation here is very crucial, very, very crucial. So don't take it lightly. Don't see it as, oh, I'm not really seeing the use case of it. So it doesn't really it's not really important. So you not pay attention. Trust me, NumPy is very, very important in data science. So that being said, let's move forward. So we're going to start with reshaping of arrays. So we have different methods that we can use to perform all this manipulation, all this manipulation that we've mentioned. So we mentioned reshaping, right? In reshaping, we have np.reshape, we have np.resize. So these are two methods that are used to reshape our arrays, right? So np.reshape reshapes an array to a specified shape without changing its data. np.resize resizes an array to a new shape, possibly adding or removing elements, right? So these are the two methods that you use mostly when reshaping your array. We have another manipulation that we can perform on NumPy, which is flattening, right? Flattening arrays. Under flattening, we have two methods that we can use mostly to perform this particular operation. We have np.flatten and we have np.ravel. So these two methods, they basically do the same thing. One thing I like about Python, right, generally, is that they have a lot, you have multiple options of doing the same thing. You have different ways of achieving a particular, someone said you can't hear me. Is it, okay, thank you. Please leave and join. So once you see that message, if you can hear me, just let that person know so I'll not be distracted, right? Okay. All right, so let's move on. So we have Flattening and Ravel bar. So both of them basically do the same thing. They collapse any array you have into one dimension. So if you have two-dimensional array and you use flatten on it, it's going to collapse it into one-dimensional array. The same thing for three-dimensional array. If you have a three-dimensional array and you flatten it, right, it's going to flatten that three-dimensional array to a one-dimensional array. So that is basically what flattening is in array manipulation. Flattening is changing the dimension to a one-dimensional array. So you can only perform flattening on two-dimensional arrays and three-dimensional arrays, right? Because obviously, if you have one-dimensional array, there's nothing to flatten again. It's already flattened, all right? So that is it for flattening, right? The next one we have here is transposing arrays, all right? Transposing arrays. So this transposing is not a new concept. So I believe some of us have heard of this. The transposing is basically switching rows and columns. So it's making the rows to become columns and making the columns to become rows. That is basically what transposing is. So if you are transposing something, you are basically flipping it. You are basically flipping it, right? So we are going to see how we can do that. So you have two ways to do it. You can use the np.transpose function, or you can just directly use this syntax that we're going to look at, right? So these are the two ways you can transpose your arrays. So we also have joining and splitting arrays. So this one might be a little bit complex, right? But is actually the idea there is basically dividing an array or splitting an array into two or more arrays, right? So if you have an array, you can actually split it, or you can join two arrays to become one, or split one array to become two. All right, so we have several functions that we can use to achieve that. We have np concatenate, right? We have np vstack, we have np hstack, we have np split. All right, so these are the functions that we'll use in splitting and joining our arrays. So we're going to look at them and see how they are used in manipulating your arrays. All right, so let's quickly move on let's quickly illustrate all these things that have been said before we move on to the next part of this class. All right, so hope everyone can still hear me. All right. Thank you very much. So let's just move ahead. All right, so we're going to be starting with the first one, that is reshaping reshaping arrays. So we talked about two functions here, right? We talked about the np dot reshape, and we talked about what np dot what resize. So let's put your brackets. Put your bracket. So these are the functions that we're going to be using in reshaping our array. So before we do that, import you have to import your library. So you come and say import numpy as np. All right. So you can now come here and create any array we want to reshape or resize. So I can come and say array 1d. All right. Let's say np.array, and I put, let's just say 1, 2, 3, 4, 5, 6, 7. All right. We have how many elements? So there's 7 elements. So we are going to be reshaping this particular array. So, but there are some things you need to pay attention to. You need to have in mind before reshaping your array. So you can see here in this note, we said that this reshape function reshapes an array to a specified shape without changing its data. So it uses the data it already have in the original array and change it to a new array based on the new shape that we are specifying. Why this resize? It resizes an array to a new shape, and while doing that, it can actually remove elements. It can actually change the data by removing or adding elements. All right, so that's the difference between these two functions that we have here. So let's just look at how we can use them. So in this case now, we want to convert this particular one. Look, let's see the shape of this array. So if, okay, to get the dimension of this particular array, what syntax or what code am I going to write here? So I want to get the dimension of this array and also the shape, the dimension and the shape. What function or what method am I going to use? I need to write out the full code, like with this variable that we have on the screen. And array1d dim, simple as in dim shape. Was that the method that we talked about? I need more responses, please. I need more responses. We are not most of us, I don't know what's happening today. We're not really participating, but please let's give response to this question. Don't just wait for someone to answer the question. No, even if someone has answered the question, I need you to still put your to answer your own, to give your response as well. All right, so most of us are saying to get the dimension, you say array1.dim, okay? And we are going to say print f dimension of the array is. All right, so that's what we're saying here. And we'll say, come here and say the shape of the array is array1d dot shape. All right, I'm just following you all. So it's your answer that we're going to use to we are putting up here. All right, what's happening? I'm getting an error. It's telling me that NumPy array object has no attribute dim. But what I'm seeing here on the responses on the group chat is dim array1d.dim. Okay, treasure, you said ndim. Yeah, I don't know why we've forgotten that, but it's n dimension, not just dim. Understand? So that's why I was waiting for us to give more responses. So you use ndim instead of dim. There's nothing like array.dim. It is array.ndim. Ndim meaning n dimensional, right? N dimensional. N is basically, you can take any number. It can be one dimensional array, two dimensional, three dimensional, right? So ndim is the attribute name, right? So that's what we're going to use here. So if you run it, you see that there's no error. It's giving us the desired output, right? Giving us the desired output. So we can actually see that the dimension of our array is one. Let me come here and put one dimensional. You can see that the dimensional of the array is one dimensional. So now I want to convert this array from one dimensional to two dimensional. A way we can do that is by using the reshape function, right? Let's see how that is done in NumPy. So there are two ways to do it basically. Reshaping, reshaping our array from 1D to 2D, two-dimensional. So there are two ways. The first method is by using the NumPy function straight up. That is np.reshape, right? So this is the method that we talked about, right? By using this np.reshape, if assuming this is your first time of doing it and you don't really know how to use it, you can just simply what combination of keys are we going to press in order to see more documentation and explanation of this particular function. So assuming you have no idea of what this function does and you want to get more understanding, so what combination of keys am I going to press in order to get those information? Exactly, Shift and Tab. So I'm going to place my cursor on this function and press Shift and Tab, and I will get this documentation. So this is a very good way of getting yourself acquainted with some of these functions. So it's the people that created Python understand that we might not remember every single thing, you understand? So they give us these things to help us to be more effective and efficient while writing our code. So can as well just go to this documentation and just read through it. So you can see the definition. Now look at this. I want us to pay attention now. This is just a side note. This is the documentation, right? You can see we have here what we call docstring. So this docstring is same docstring I taught us initially. So why they were defining this function, which is reshape, what they included in that docstring are all these things that we have here, all these things. So this is like explanation of the entire function. All right. So that's why we can see all this. So I think it stops somewhere here. So this is where the docstring stop, right? So if they had not included anything in the docstring, once we use Shift Tab, we're not going to see much here. We're not going to see an explanation like this, all right? So this is the importance of docstring. That is the importance of docstring. So other people can see your, understand how to use your function. You understand? So you can see the parameters here. These are the parameters for this function. We have your array. You put your array, all right, and then your shape. You put the shape that you want it to take. If you scroll down, you can see some examples here, right? You can see some examples. You can see that an array was created using np.arange, right? So you created this, and then he gave us this, and then they reshaped this. So this is just a very good way to quickly jump on something that you don't previously know. So just keep that at the back of your mind. In case you meet any function that you've forgotten how to use it, you can just quickly use Shift Tab instead of going to Google and asking Google, how do I do this? You can quickly just use this particular shortcut to get the answers. All right, so in this case, we want to reshape the array 1D. So we're going to come here and pass the array 1D as the param argument. And then the second argument that follows is the shape that we want to shape it into, or we want to like reshape the original array into. Now, if I come here and now let's assume I want to change it to a two-dimensional array, I can say, all right, let's make it 7 by 1. If I come here and say 7 by 1, this is actually a two-dimensional array, right? Here we have 7 rows and 1 column, right? So now there's something you need to pay attention to. The resulting shape has to be equal to the original shape. The size of the resulting shape you want to change it into has to be the same size as the original array. So let me come back again. Now let's quickly just print out the size of this array. If I say the size of the array is array 1d dot shape. So you can see that, okay, sorry, size rather. Because that size basically means the number of elements in that array. So the new array we are creating, when we're using this reshape, has to be equal to the original size. So if I come here and say 7 by 2, what is the new size of this array? This new size is going to be what? This is a question. What's going to be the new size of this resulting array that we are shaping? Exactly. It's going to be 14, right? Because you are going to be having 7 rows and 2 columns. So if you count all the elements in that new array, it's going to be 14. And 14 is not equal to the original array. We have just 7 elements here. So where do you want it to generate elements from? You get. So using this reshape function, it will give you an error. So if we run this, you're going to get an error, right? So the error is going to be cannot reshape array of size 7 into shape 7 by 2. Understand? So you are going to get an error. So that is something you need to pay attention to while using reshape. Let's try resize. See now, this is different between reshape and resize. Understand? Reshape cannot create new elements to fill in the missing numbers of elements, but resize can actually generate those new elements, right? You can see based on what we said here that reshaping or np.reshape reshapes an array to a specified shape without changing its data. It's just like list and tuple. Tuple cannot be manipulated. What you have is what you have. The same thing as reshape. Why list can be manipulated? You can add and you can remove, right? So the same thing for resize. So just use that understanding to understand this particular reshape and resize difference. So that is basically how to reshape array using resize and reshape. So for resize, you can actually get a new array of a bigger size or a smaller size. So let's come here. Let's say I want to make it 3 by 2. It's going to be 6, right? If I run it, it's going to give me an array. Understand? So it looks for a way to remove some elements, right, while maintaining the shape or the resulting shape that you want. So in this case, you can see we have 1 to 6, 1, 2, 3, 4, 5, 6, but 7 is gone. Understand? So that is just how this resize and reshape function is used in NumPy. So let's just quickly just give a few examples before we move on to the next one. So if I come here and say reshape, so the only thing I can do here is to reshape to 7 by 1, right? There's no other combination that is this network issue a general thing or just this particular person? Someone is complaining of network and someone is observing the same thing. So I want to know if it's a general
Just the
issue
person.
or
Just the
just
person, not you.
happening to few persons. Okay, great. So with reshape, we can reshape the original array from shape 7 to shape 7 and 1. But just to get you to understand it better, let's add one more number here. Let's say 8. So if you run this, we now have a size of 8, right? So if I come here, I can reshape it to several combinations of rows and columns. So can someone just list out like 4 combinations of 4 arrays or 4 array shape that I can generate from this original array that we have here. I've changed the array size here to 8, right? So I need us to just give me like at most 4 resulting array shape that we can put in this particular bracket. Exactly. Hazan Kolawole, nice. 2 4 1 8 4 4. Are you sure? 4 4. 4 times 4 is what? 16, not 8. You understand? So that is what I need you to understand. What you are putting in this bracket, if you multiply both of them, it should give you the same number as the size of the original array. You understand? So that is basically how to go about reshaping your array. So if I come here and I say 2 by 4, you see I'm going to get a new array, right? 2 columns and 4, sorry, 2 rows and 4 columns. If I come and say, okay, so let me go with the 4 by 4 that one of you said. If I go by 4 by 4, I'm going to get an error. Why? Because the new shape that we're trying to get is greater than the original size. Do you understand? So the size of this original array is less than the resulting size that we want to create. So it will give us an error unless we use resize. You understand? Unless we use resize, right? But if you are using reshape will always give us an error when the size is not equal to the original size that we have. So what we can do is do 4 2. You understand? So in this case, we have 4 rows and 2 columns. We can do 1 and 8, right? 1 row and what? 8 columns. I can do 8 1, 8 rows and 1 column. So that is it. You understand? That is it. Yes, we are still coming to that. Someone just pointed out something. Adeleke Emmanuel, you just pointed out something. Yes, we are going to come to that. So now you can actually reshape to 3-dimension too. Remember, we have 1-dimensional array, we have 2-dimensional array, we also have 3-dimensional array. So you can actually still reshape your 1-dimensional array to 3-dimensional array. So in this case, you're not going to put 3 values in that bracket instead of 2. So the 3 values will represent the the first one, which represent the different 2-dimensional arrays, and the second and third one, which will now represent the size, that is the rows and column of each of the 2-dimensional arrays in your 3D array. All right. So if I come here and I put 2 2 2, I'm going to get a 3-dimensional array. If I run this, you'll see this is a 3D array. You understand? It has 2 channels or 2 2D arrays, and in those 2D array has a shape of 2 by 2. That is 2 rows and 2 columns. If I come here and say, what else can I do? Is there any other combination that we can have here? Let's say 4 1 2. Let's see this. So we can also have this combination 2 4 1 2, right? We can have 4 2 1, right? We can have this. We can have 1 4 2. Basically, we can have this, and so you can just play around with exactly. You can also have 8 1 1. You can have 8 1 1. Like you basically have 8 different. So you are now understanding how you can reshape, how you can manipulate your arrays using np.reshape, right? So that's it for reshape. So the same idea applies to resize. I'm not going to go in depth into resize, but if you are using resize, you can actually use resize to do the same thing, to give you the same output. But resize actually allows you to use a size that is not equal to the original size of the original array. It allows you to reshape your array into a size that is bigger or smaller than the initial array. So it is more flexible than reshape function, right? So if I come here and say 8 by, or let's say 4 by 4, or let's say 4 by 3 by 2. What's going to be the size? What's the size of this resulting array here? Remember, the size of the original array we are reshaping is 8, right? So this resulting array now, what's going to be the size? Exactly, 24, right? So if I run this, you see I'm going to get a new array. Regardless of the shape that we are putting, it will surely give us a new array, right? So you can use the resize to achieve this, but once it is reshaped, you know that your size has to be the same thing. So you can do that for 2D2, you can do that for two-dimensional arrays, you can do that for just basically 2D and 3D arrays, right? So that is it for reshaping and resizing of arrays. All right. So if you have, let's say your original array is 2-dimension, you can actually still resize it. Let's say our array here, let's assign this to array 2D. So I have this array here. Okay, I have this two-dimensional array of shape. If I print the shape out, it should give me 2D.shape. So the shape is 4 by 3. I can actually reshape this my two-dimensional array to become a different shape, but still maintaining 2 dimension, right? So if I come and say array 2D dot reshape, and let me use np dot reshape and say array 2D, and come here and say we have the size of this array is 12, so I can say 6 by 2. All right, so it reshaped the array from 4 by 3 to 6 by 2. If I say 2 by 6, we see it reshaped it to 2 rows and 6 columns. So you just look for those two numbers that if you multiply together, it will give you the size of your original array. And the size of the original array is 12, right? That is 4 times 3 is 12. So anything that can give you 12, if you combine it, you can use it as your new shape, all right? So that is when you are using reshape. But when you are using resize, there is no limit. You can just use any shape that you want. So I told you that there are two methods of doing this reshaping. The first one is saying np.reshape or resize. The second method is basically just calling the array. Second method is basically just calling the array. Let's say array 1D and saying reshape. All right. So when we call it and say reshape, what you do is just to add the new shape directly. And you can say the array 1D is 8. So you can say 4 by 2. Right. So this is actually more straightforward. You don't need to say np.reshape. You just call the array that you want to reshape and then add the method. So it automatically knows that, okay, this is the array that you want to reshape, and then you're passing as argument the new shape that you want the array to have, right? So that is basically for reshaping. You can do the same thing for resize, right? Resize, right? So yeah, you can do the same thing for resize, and you can pass it to a variable and print the result out basically. So the method that you would want to use depends on you. So you can either use this first one, np.resize, indicate the array here and followed by the shape, or just call the array straight out and then let NumPy know if you want to reshape or if you want to resize. All right. So that is it for reshaping and resizing. So we'll move on to the next thing we have, which is flattening. Flattening of arrays. So we've looked at how we can reshape array from one shape or one dimension to another or different shapes, right? We can also flatten arrays from a higher dimension to one dimension, all right? So the function or the method that we can use to achieve that is the flatten method, np.flatten or np.ravel. So these are the two methods you can use to flatten your array. So let's basically let's look at how we can achieve that. So let's use the other array we've created, array 2D. So we have this array here. This is a 4x3 array. I want to flatten this array, right? So instead of you can actually just come here and say np.shape and say what's the size now? The size is 12. I can just come and say 12, right? So it will convert it to a one-dimensional array for me. Like I've basically flattened it. So you can still use the reshape function to flatten your array, right? But that's why I said Python has different ways of doing the same thing. But the flatten function is dedicated to just flattening your array. So you don't have to indicate anything. You don't have to tell indicate any shape as the parameter or all of that. So you can just come here and say array np dot flatten. So in case you don't know how to use it, you can always press your shift sorry, I think it should be array 2d dot flatten, right? So if you don't know how to use it, you can just press your shift and tab and it will show you the documentation. You can see here it returns a copy of the array collapsed into one dimension. All right, so that is basically what the flatten does. So it doesn't really receive any parameter, right? This parameter is not really important. So you see an example below. You can see that they have a two-dimensional array here and they flatten it to one dimension, right? So basically you just understand it straight. You basically understand it if you've forgotten how to use it, you just use your shift and tab and it will show you the documentation and all of that. So this is straightforward. There's really nothing else to say about this flatten. The same thing goes for Ravel. So if we come here and say array 2d dot Ravel, I want to be sure it's the same syntax. All right. So you see we have the same output, right? So there are just two different ways. So you can see when we use our shift tab, it tells us that it returns a flattened array too, right? The same thing with the flatten function. All right, so that is what it does. So if you have a three-dimensional array, let's try to create a three-dimensional array here. Let's say array 3D equal to, let's use the 2D and reshape it to is 12, right? That is 4 times 2. All right, so we're going to use array 3D here. So you can see it flattens it to, right? From 3 dimension, it just flattens it straight to 1 dimension. So that is what flattening does. So that sometimes you might have 2-dimensional arrays and you just want a list of all the values in that particular array. So you just use your flatten function to just flatten it and you have a list and you can now use it to do whatever it is you want to do, all right? So that is basically for flattening of arrays. All right, so the next one we have here, let's see. Next one we have here is transposing, all right? Transposing of arrays. So this is also straightforward. Transposing is a very common concept. It's basically flipping something flipping your rows to become columns and flipping your columns to become rows. All right, so the way to do that is by using your function tool. That is, should be np dot transpose. So just know that anything, if you can, anything that is like has to do with manipulating of array, you can always use your array directly with the function. So you can say array 2d dot transpose. Most of them actually, right, that would work, right? So if you come here and put okay, let me comment this out. Transpose. So you can use it like this, right? By calling your array and then calling the function, or you can come here and say np.transpose and put your array inside the bracket as a parameter. You can come here and just put 2. So it will do the same thing. So just know when manipulating array, you can use either of this method, right? So anyone that is more convenient for you, right? So that is just keep that at the back of your mind. So we have transposing. So let me print out the original array here. Print array 2D. So you can see this is our original array. This is 4 by 3, right? So when we transpose this array, it becomes what? If we flip this array, this particular array that we have here, that is basically transposing it, what is going to be the new shape of the array? So this is just a very cheap question, right? So just to be sure that we are still following. So if we flip this, what's going to be the new shape? All right, exactly. So we are going to have, let me print out the shape. Come here and print array 2D dot shape. All right. Come here and just say print all right. I'll come here and say print array transpose. That is array transpose. I'll come and say array transpose dot shape. All right, so all right, so this is what happens when you transpose your array. The initial array here is 4 by 3, right? As you can see here, 4 by 3. But when we transpose the array, we're going to be having 3 by 4. So everything on the column was flipped over to the row, and everything on the row was flipped over to the column. That's basically what happens there. So if we use the let's use the 1D here, right? Let's use the 1D. So you can see one-dimensional array. What is it? Yeah, did we change anything? Okay, let's use the 3D, I think. So if we are using the 3 dimension here, you can see that we have the original shape of the 3-dimensional array to be 3 by 2 by 2. But when we flip it, it's going to be 2 by 2 by 3. So it basically flips the transposes the array, right, from back. It brings the value from the back to the front and then just aligns it in reverse. That is what happens. That is basically what transpose is, right? So if you have a table and you want to transpose that table, you just flip it over. That is what transposing is. So that sometimes you need to transpose your array, but this is a concept that is general. All right. So once we start doing pandas, you would understand the importance of transposing. I told you that there are two methods or two ways to transpose your array. You can use the transpose function, or you can just directly call this T syntax, right? By coming and saying array 2D dot T, right? Second method, second method for transposing arrays. So I can come and just say array 2d.t, like just straightforward like that to transpose our array, right? So you don't even need to write transpose or do anything. Just call your array and use dot t syntax on it, and it will automatically transpose it for you. If I have 3 here, to automatically transpose it. All right. If I have, so this is just how you transpose your array. You can use this first method here, which you've illustrated. You can also use the second method here, which is just calling on dot t on your array that you already have. All right. So that is for transposing. So what have we looked at so far? We've looked at array. We are looking at array manipulation. We started by looking at reshaping of arrays. All right, so let me give that what was wrong with me this when I'm typing. All right, so we looked at reshaping arrays, I showed you two methods that you can use, the reshape method and the resize method. Reshape method is almost similar to tuple, which is not mutable. And this is just to help you understand it, why this one is like the list, right? Like tuple, why this one is like list. It has the attribute of tuple, right, in which you cannot change the content. But for resize, you can actually change the content. It does not have to be exactly the same size as the original array. Okay, someone is asking, must it be on the lowercase? No, it should be capital letter. These are syntax. If you write small letter, it's going to give you an error. Remember, I told us initially that Python is case sensitive. Python is case sensitive. So you use the capital letter T for transposing, capital letter T, right? So you just put that at the back of your mind in case you have any error from that. All right, so we looked at reshaping, we looked at resize and reshape function. Then we moved to flattening of arrays, looking at how we can flatten arrays using flatten function and unravel function. So flattening of arrays is straightforward. It's converting two-dimensional or three-dimensional arrays to one-dimensional array. You can actually achieve this same thing with reshaping, right? But flattening actually helps you to do it more efficient, right? More efficiently. It's straightforward. You don't need to include any shape or what have you. So we looked at transposing of arrays, right? You can actually transpose your arrays, which basically means flipping your rows to your column and your column to your rows. Like that is like reversing the shape of your array. All right. So we looked at the different methods. We looked at the np.transpose using the transpose function. And we also looked at using this particular notation, which is .t. All right, so I think this is the more easy one, the easier one, and I feel that is what most of us will be using by transposing over our arrays. All right, that's it. We're going to be moving on to the other one here, which is concatenating or joining arrays. Concatenating or joining arrays. So now NumPy provide functions that we can use to join two arrays, right? Let's say you have two arrays and you want to combine them to become one. It's possible. And we're going to illustrate that now. So let's just quickly look at it. Joining two arrays. All right. So if we see here, you can see that we have three functions here for joining or concatenating our arrays. We have the np concatenate function, right? We have the np vstack function, and we have the np hstack function. All right, so I'm going to explain how we can use these three different functions on our array, right? On in joining different arrays. So after that, we're now going to look at how we can split our array. So this split can be a little tricky, right? But we're going to look at that. So let's quickly look at using the concatenate function. So come here and say, let's create two arrays. So let's come and say array one. So np.array. Yeah, trust me, NumPy is the most, out of all the things we're going to be doing, NumPy is the most boring, right? Because it's just like mathematics involving numbers and all of that. So it's not really concrete like other things we'll be doing. I remember the Python functions, all these things that we did before, they were pretty much relatable, right? So just follow me along here. You need to understand this. If you don't need this, you won't be I won't be teaching you. So please and please try as much as you can to follow up with everything that is being explained here. As much as you see it to be just there and boring, it is the most fundamental concept in data science. NumPy, very, very important, very, very important. So after we finish NumPy, you will now be seeing the more interesting things that we're going to be doing in pandas, data analysis, working with data and all of that, and building or creating visualizations, bar charts, and everything that we'll be doing moving forward. But for now, we need to understand NumPy, all right? So let's just finish up with that. So we're going to be looking at how we can join two arrays, right? So let's just quickly create two arrays here. Let's create this 4 and come here and say 2, 7, 8, 4. All right, so this is array 1. Then we'll come and say array 2 np.array. I'll come here and say 4, 1, 1, 2. I'll say 2, 8, 5, 5. All right. So we have these two arrays now, array 1 and array 2. So let's assume they were separate initially, and what you wanted to do is to work with these combined arrays. You want to combine it. There was a need for you to combine these arrays. So there is a simple way we can do it in NumPy using the concatenate function. So np.concatenate will do that for you. Concatenate. So if the same thing applies here, if you need to understand it better, just press Shift and Tab, and it will just pop up the documentation for you. You can see the explanation here. It's join a sequence of arrays along an existing axis. All right. So it joins arrays, right, along an axis. So there are two important parameters, two important arguments you need to specify in this function, this concatenate function. The first one is the array or the arrays that you want to concatenate, right? So you have two arrays here. You need to put them in a tuple. So come and say array 1, comma, array 2. Right? If you have more arrays, you can actually add them here continually like that. So, but in this case, we have just two arrays. Then the second argument is the axis in which you want to concatenate these arrays. So in this case, I want to concatenate these arrays along the x-axis. So in this case now, I've told us the x-axis and the y-axis, and the numbers that represent them. So can someone just remind us of what numbers represent the x-axis and what number represents the y-axis? So just quickly, please, let's answer that and move on. What number represents the x-axis and what number represents the y-axis? Okay, most of us are saying x-axis is 0, y-axis is 1. Yes, you are correct. So based on what we've discussed initially, x is represented by 0, y-axis is represented by 1. So in this case, we want to stack them along the row, that is the x-axis. So I'll come and specify another parameter. This is a keyword argument and assign and specify it to be 0. So what I'm saying here is concatenate or join these arrays along the x-axis. So if I run this, I'm going to get a new array. And you can see what happens here, that we've joined, this is the first array here. You can see this is array 1, and now this is array 2. So the concatenate function concatenated these two arrays along the x-axis. If I come here and change the axis to 1 and run it, you can see that it's now concatenated it along the y-axis, right? So this is from 3 here to 5 is your first array. From 4 here to 2 is your second array. So you can see that it is straightforward, right? But you can actually run into error if the shape of your arrays are actually not aligned. So in this case, let's assume my second array is this. It has just 3 columns, and I want to concatenate it along the row, right? I come here and say 0. Now, it's going to give me an error. Why? Because the number of columns in the first array is not the same as the number of columns in the second array. So it will not understand how to align each of the elements in these two arrays. So it can say, okay, 3 and 2, it will put 4 and 2 under 3 and 2. It will put 1 and 8 under 4 and 6. It will put 1 and 5 under 5 and 8. But under 5 and 4, what is it going to put there? There is nothing. So it's going to throw an error, right? So for you to be able to do this, you have to make sure that the shape of these two arrays are the same. The shape is the same, basically, right? So in this case, if you want to concatenate along the x-axis, we have to make sure that the columns align. The number of columns in array 1 and number of columns in array 2 are the same, right? So if I come and say, I'll have to come and say 3 and 5, right? So if I do this, I'm going to obviously get a concatenated array, all right? So it's actually very straightforward as that. If I come here and add another row to my array and say 1, 2, 2, 2, you see that there will be an error if I'm trying to concatenate along the column axis. Why? Because the number of rows in the first array is not equal to the number of rows in the second array. If I come here and say 1, I'm going to get an error. Why? Because just trying to join this one to this place like this along the y-axis. So this 4, 1, 1, 3, it will be placed after this 3, 4, 5. I will place here 4, 1, 1, 3. Then 2, 8, 5, 3 will be placed after 2, 6, 8, 4. It will be placed here 2, 8, 5, 3. But what will now be placed after this 1, 2, 2, 2, right? There is no value, or there is no there are no elements that can be attached to this. So the function or NumPy will now throw an error, right? You can see that if you read the error, you see that it said all the input array dimensions except for the concatenation axis must match exactly, right? It must match exactly. So you have to ensure that the axis at which you are trying to join has the same number of elements, right? So it will not give you any error. So just come here and just increase the shape. You can just say C777, right? And you are good to go. So you can see the resulting array. So you've joined the two arrays into one. So that is basically how you can concatenate arrays in NumPy. This is one way you can do that. So we also have two other methods which you might not really use because this concatenate function can do it for you, right? But I'm still going to explain it regardless. So we have the using h stack and v stack functions. All right, so we can use np.hstack, right? What this function does is that it concatenates the arrays horizontally. It does it like this concatenate function when axis 1 is equals to 0. So if I come here and say array 1 and then array 2, you will see horizontally is like from left to right, not up to down. So you see that it does the same thing that this concatenate function does when the axis is equal to 1 actually. When the axis is equals to 1, while vstack performs the same thing when the axis is equals to 0. So vstack and hstack, they are just redundant functions. If you use concatenate or if you know concatenate, you don't need to use vstack and hstack. Concatenate can just do everything for you, but you have to specify the axis in this particular place or in this particular function. All right, so that is how you can join or concatenate arrays. All right, so you can apply it to different dimensions. All right, so you just have to understand the dimensions that you are trying to concatenate, the shapes of the array, and these shapes must align. All right, these shapes must align. If it's one dimension, you would obviously know the axis on which to align it. If it is 3-dimension, you should know the axis in which you are trying to join or concatenate those two arrays. All right. So that is it for concatenation. If you have any question, you can just keep it. When it's time for question, you then ask your question. So let's move on to splitting of arrays. Splitting arrays. So we've looked at how we can join arrays and how we can concatenate arrays along different axes, right? So let's look at how we can split arrays. Right, so let's assume we have an array. Let's assign this particular array to array 4, or let's say 3, right? And come here and say array 4. So we're going to have these two arrays. So we have array 3 here. Now we want to split these arrays now, this particular array, into different arrays. So the function to achieve that is the np.split function. So this function is you need to understand the argument that you should pass in this function, into the function. So to do that, let's just use our shift and tab. So we'll go over it together. Now you can see the documentation here. It splits an array into multiple sub arrays, right? So it takes parameter, it takes an array, the array you want to split, right? This is the array to be divided into sub arrays. Then it takes another parameter, which is indices or section, all right? So you see that as we move forward. Then it also can take axis, but it is optional. All right. So if you scroll down, you're going to see the different examples we have here, right? So you can see here we have a particular array that was created, and we can see how np.split was used to split that array into 3 different parts. All right, 3 different arrays rather. So let's quickly see how to do that. Let's quickly see how we can do that. So we have our array here, array 3. I want to split it. So if I come here, the next, we have two important parameters. The first parameter is your array, while the second parameter is what we call indices, all right? Indices. So it's usually something like this, right? So I think it should be let's be sure that okay. All right, so let me just quickly pick an example from here. Okay, it's comma, not this thing. So sometimes I can actually forget the syntax. So come here and say this closing parentheses. So now you can see what we're having here. We basically split this array into 3 different arrays, right? I will explain exactly what these numbers mean here, but you can also include the axis at which you want to split. Let's say I want to split across the y-axis, right? I'm going to say equal to 1. Now you can see in this case, we have 3 arrays. We have this first array, we have the second array, and we have these third arrays. Now, how we achieve this or how we get this output is based on this number that we have here. All right. So this number will determine how the splitting will be done. So this number corresponds to the index of this array we have here. So in this case, the first number here is 2. So what NP.split will do is that it will go to this original array that you want to split and start from the index 0 and stop at index 1. Remember that Python doesn't always include the last index. So it will start from the index 0 and stop at index 1 and split it. You can see that the first output here is just the first 2 indexes. That is index 0 and index 1. Now, index 2 and 3, the second number here means the second split would be between index 2 and index 3. So in this case, we are going to be getting only this index 2 here, right? Because this particular index is not inclusive according to Python. So that is the second split. Then the third split will now be the remainder of the remaining array that we have, right? So you can see that from here, we have from 5, 4, 1, 1, 3. So you can see the third array here is 5, 4, 1, 1, 3. All right. So let's change this to 5. If we come here and change this to 5, I'm going to see that the output is going to be different. All right. The first array we have here is still corresponding to the the first output we had, right, from index 0 and 1. Then the second output will start from index 2 and stop at index 4. So this is index 2, right? 2, 3, 4. So these 3 different columns will be assigned or will be split to, right, as the second array. And then the remaining array we have, that is this 1, 2, 3 rows, will now be the last array we're going to be having in our split, right, in this split function. So this is can be confusing at first, but you just need to understand these numbers here, what these numbers are doing. All right. So in this case, if we have just one number, you see we are going to be having just 2 outputs here, right? So the first output will be just the index from 0 to 1, basically, and then the remainder of the array would be the second array we have here. So if I come here and say 5, right, I'm going to have this. If I come and say 4, I'm going to have equal number of columns, all right, because it's going to be taking 1, 2, 3, and then it's going to be taking 0, 1, 2, 3, all right, as the first array that is splitting, and then taking the second part, which is 4, 5, 6, 7, all right. So that is basically how we split arrays using NumPy. So if you can just do, you can manipulate or play around with it by putting different numbers here. So you can put 2, 3, and 5. All right, it will give you this output. So just ensure that you understand the indexing in your original array and where you want to split from and where you want to start and where you want to end. All right. So this axis here is telling us that we should split according to column, across the columns. If I change this to 0, it's now going to be splitting it horizontally. All right. In this case, it's going to give us an error because there's no index 3 here. The index horizontally stops at where? So to know if we are following, what is the last index in this particular array, row-wise? That's great. So yeah, the last index here is 2. So if we use this particular splitting method, it's going to give us an okay, basically it will just give us empty arrays, right? It will split the one that it can split basically, and the remaining arrays here would be empty. So the first one is from 0 to 2, right? So it will split the first row, that is row 0, and split the second row, which is row 1, and assign and bring that one out. And then the 2 from 2 to 3, or based on what we put here, is going to now bring out or extract this other array and assign it to the next split. And it will now look at this other index that we indicated here, index 3. There's no index 3, all right? So it's now going to just make an empty array here and make an empty array here for this last index that we have here. So that's basically how we split arrays in NumPy. So if you want to extract the arrays you splitted here, let me just change this to 1. If you want to extract the arrays, you can basically just assign this to, you can assign this to a variable and then use indexing. You can use indexing to extract each of the array, right? Because the output or the return value of this function is a tuple containing multiple arrays that you split. So each of the array is an element in that tuple. So you can actually index each of those arrays. So in this case, if I want to extract the first array here, let me come here and print it so you see what I'm doing. I'll print splitted arrays, right? So you can see here we have the first one here, right? We have the first one here. We have the second one here. We have the third one here. And we have the fourth one here and this one, right? So this is, okay, we have 1, 2, 3, 4. We have 4 arrays here. So each of these arrays have an index, all right? So if you want to get this first array that is here, we're going to call the array that you assign it the function to a variable and then call the first index, right, which is 0. So the array that corresponds to the first index is this 3, 4, 2, 6, 1, 2. So it's going to be extracted from this tuple, or this list rather. So this is actually a list, not a tuple. So if you want to call the second array, we'll just put 1 here. You see that we have the second array. If you want to call the third array, you'll put 2, and then the same thing for the rest of the array. So you can actually just extract them and assign them to a variable. So I can come here and say first array equals to this. I'll come and say second array equals to splitted arrays 1, and then just copy this, say third array, fourth array. All right, I'll come here and say 2, 3. So let me remove this. So you can see that I've assigned all the arrays that I splitted from this particular function to each variable. So each of these variable now corresponds to each array that I have here that were split from this original array. So if I come here and say the first array you can see that is the first array, right? Give us the output. If I come and call the second, you can see it here. Same thing for the third. You can see, and also for, so depending on how many splits or how many arrays that you have in the split that you did, you are going to have a corresponding number of arrays in this indexing too. All right, so that is basically how you split arrays in NumPy. Now this is a very tricky is actually very tricky. But one thing you just need to know in this splitting is to understand this second parameter here, or the second argument. Just know what they are pointing to in your array, right? These things that we have here, they are indexes. They point to the index of the array you want to split, all right? So this first one here tells you that the first split should stop at this the second indexing, right? With the second index not being inclusive, all right? So after the first array has been split, then it will now continue from here and then stop at the third index, all right? With the third index not being inclusive, but in this case, you'll be getting only the second index. So after you've done that second split, then 3 mean you now start from the third index and extract the element from the third index to the fifth index, all right? So if the fifth index is the last index, then it will stop there. But if you remove this 5 here and just put 2 and 3, so it will first do for this 2, do for this 3, and from this 3, it will just take every other thing that it has after this 3, right? So it didn't specify any limit. You just take the remaining values in that array and assign it or extract it as the last array in your split. All right. So that is basically how you split arrays in NumPy. So we've looked at concatenating arrays, right? We've looked at how we can join two arrays, either horizontally or vertically, and we've looked at how we can also split array. So this is just giving mathematics vibe. I know most of us didn't like mathematics, and mathematics can be very abstract and boring. But this is basically how you use. These are the things that you need to know in NumPy. All right, so we can't actually run away from it. You need to know them. It's not like you'll be splitting arrays all the time and all of that. But having an idea on how you can work with arrays would make you very, very good as we are moving forward, because every other thing we're going to be doing, they are going to be based on NumPy. All right, so if you have an understanding on how to work with arrays, manipulate your arrays, you will not really have much issues. And for some of us that want to be even going further and going into machine learning and all of that, you see that you would make use of arrays and tensors and all of that even much more. And so this particular knowledge would be very, very useful, right? So you can always go back to this video and rewatch so you understand. And this particular notebook will be made available to you after this class, so you can use it as well alongside the video to get more understanding. That is one of the importance of attending class. Once you attend a class, you might not necessarily pick up that thing that you need to pick up, but when you now go back to now rewatch the video and look at these materials, it will now start making a whole lot of sense to you, right? Because you are now practicing, you are now seeing it in a different light. But if you don't attend class, right, and you just go straight to the video and watch it, it will be more difficult for you to understand it than those that attended class. So that is just one advantage of attending these live sessions, right? So even if we are always recording and we are taking attendance, it's still beneficial that you still attend the classes. All right. So let's move on to what we have. The remainder of what we have for today. So we are done with array manipulation basically. So what we did in array manipulation, we looked at how we can reshape our arrays. We looked at how we can flatten our arrays. We looked at how we can transpose our arrays. We looked at how we can concatenate or join arrays. And we also looked at how we can split arrays. All right, so these are the things we looked. These 5 different manipulation techniques. All right, so you are definitely going to be tested in your assignment. So let's move on to the next thing we have. I think this is the last thing we have for today, aggregation function. All right, so we're going to quickly look at aggregation functions in NumPy. So what are aggregation functions? Aggregation functions are functions that are used to summarize or reduce your data to contain a particular summary, all right? Or to give you a summary or a statistics to understand your data better. So these functions are essential for data analysis and statistical computations. So we're just going to look at them. They're actually very straightforward. Trust me, it is not as it will not turn your eye as the other ones that we looked at, but this is straightforward. You just need to understand some few things which we are going to be mentioning. So in this particular section, we have few aggregation functions. We have the sum function, right? np.sum. We have the mean aggregation function. We have the mean. Okay, let me quickly go here and just write out everything. Aggregation functions. All right, so let's look at them one after the other. We have the sum. So which array are we going to use now? Which array are we going to use? All right, let's use this array 1. So we have the sum. So sum is, I told us initially, I think yesterday, give us the difference between sum and add. So who can remind us of what I said regarding that? I told us that there's a difference between sum and add. So can someone just quickly just tell us what differentiates these two functions? Exactly. I actually want more response. I want more response. I want this class to be interactive, right? So please don't just stay there. Just say something. You understand? I don't want just a particular set of people saying the same thing over and over again or responding just the same set of persons. I want we're up to 91 in this class, all right? And I have not seen more than 20 responses at a time. That is actually not good. So please let's try to participate in everything we are doing. All right. All right. So sum adds all the elements in an array, adds the universal function. Sum is aggregate. Sum adds the value. Sum adds up the numbers in the array. Okay. Yeah. Okay. We Exactly. There's one I just saw now. Marvelous Bassi. You said something that I wanted to hear. Sum adds all the elements in an array. Y add np.add adds two arrays. Understand? That's one thing I wanted to hear. Add np.add adds two arrays, while np.sum sum up one array. It sums up all the elements in a particular array, while add actually take two array and perform element-wise operations on those arrays. That's the difference basically, right? So let's just look at how we use sum here. So np.sum, as we all know, we know what sum is, right? So let's use the array one. So this is the array we are going to be performing our sum operation on, right? So all right. So if I come and say np.sum and say array one, what's going to happen is that it's going to add everything in that array, every single thing, to one number. So if you come here and start counting it manually, right, saying 3 plus 3, 3 plus 4 plus 5 plus 5 plus 2 plus 6 plus 8 plus 4 plus 1 plus 2 plus 2 plus 2. If you add everything, you are going to get 44. Do you understand? You are going to get 44. That is exactly what np.sum is doing. np.sum just takes all the elements and add them together. That is why we call it aggregation function. It aggregates everything. It compresses it. If you know what aggregation means, aggregation is gathering a lot of things together into one particular place, right? So that is what np.sum function. That is what all the functions that are under aggregation function we do. Then we try to aggregate everything to one particular value, or maybe a set of values that kind of represents the entire thing, right? So sum is the simplest one here. All right, sum is the simplest one. So we have sum. The reason why we don't have anything like subtract is because obviously it doesn't make sense that subtract is an aggregation. What is the aggregating? So you understand. So np.sum here will so we might, I don't know, but basically what we have is np.sum. We also have np.mean, right? If I come and say array one, you can see that it has given me a mean, which is 3.66665. All right. So it is aggregating everything and calculating the mean of the elements in our array. So whether it's a two-dimensional array, or whether it's a three-dimensional array, or whether it's a one-dimensional array, it doesn't care. What it cares about is picking all the elements in that array and adding everything together if it is sum, or calculating the mean if it is mean. All right. So that is what this values. That is what it does here. So the other one we have here is np.mean. So this one is minimum. It gets the minimum value of all the values we have in our array. So if I come and say array 1, you see that the minimum value is what? 1. Same for max. We have max array 1. The maximum value is what? 8. So this is an aggregation function. It is giving you a single value that represents the entire, or that gives you a meaning of your entire array. All right. So that is basically what aggregation function is. But now you can actually specify the axis that you want to aggregate. Unless it is one-dimensional array, you have to specify the axis when working with aggregation functions. So in this case now, let's come here. In this case, if we use np.sum, it basically gives us the sum of everything. But in this array, we have rows and columns, right? So we can actually specify or tell our sum function that, okay, I don't want it to just give me all the sum of everything. I want you to give me the sum of all the values in the column or in the columns, right? So if I come and say axis is equal to 1 and run it, this is what I'm going to get. I'm not going to get one value. I'm going to get 3 values that corresponds to what? The 3
rows that we have here. So what it is doing is that it is aggregating the columns. So it is compressing these columns, these 4 columns, into one by adding everything. So 3 plus 4 is what? 7. 7 plus 5 plus 5 will give you 17. That is the first value for this first row. So to come to the second row, aggregate all the value in the second, all the value in the columns to give you 20. Come to the third row and aggregate everything to give you 7. All right. So that's basically what the axis parameter will do here. It will not now give you, it will not calculate the sum of everything again. It will now calculate the sum of all the values according to what? Aggregating the columns. All right. So you're going to have 3 values depending on the number of rows you have here. So if I come here and say 0 and I run it, I'm going to get 4 values. What is happening? It is aggregating the rows here. The rows are, this is the first row. This is, where is the first row again? This is the first row, right? But it's aggregating the column for that particular row, or the different rows, right? This 3, 2, 1, aggregating it into one. Come here, aggregate these 3 rows into one. Come here to aggregate these 3 rows into one. Do the same thing for all the rows here, and it will give you 4 values that corresponds to the 4 columns. So it has aggregated the rows. So this axis here represents the particular axis in which you want to aggregate. If you don't specify axis, it will aggregate every single value in that array. All right. That's basically what this axis does here. So the same thing applies to this other functions. If I come here and say axis is equals to 1, it will give us this. It will give us the mean value, right? To give us the mean value across the columns. It will aggregate the columns and give us a mean. Aggregate the second it will aggregate the columns of the first row, right, and give us a mean. Aggregate the columns of the second row, give us a mean. Aggregate the columns of the third row and give us a mean, right? That's basically what it does. So if I come here and say 0, you can see it will give us this. So you can say that it is aggregating for this one here, for this one, you can see that it's actually aggregating the rows, right? It's aggregating the rows here. It's aggregating first row, aggregating second row, aggregating third row. The reason why I'm saying column is because you know that 1 corresponds to what? Columns. That is the y-axis. Y0 corresponds to x-axis, which is row. So that is why I was using that. I was explaining it that way. But if you just want to explain it as it is, when you put 1 here, what it does is that it aggregates each row. It aggregates each row. All right. If you put 0 here, it will aggregate each column. It will aggregate each column and give you 4 values depending on the number of columns there is. So that's basically what the axis parameter. So depending on how what you have or the function, it will do that for you. So for your mean function, it will look at for this axis, it will look at the row and check for the minimum value. So in this first row, the minimum value is 3 to give us 3. In the second row, the minimum value is 2 to give us 2. And in the last row, the minimum value is 1 to give us 1. Right. So that is basically how this aggregation function works. So you use it in line with axis to specify the axis in which you want to aggregate. All right. So if you do not specify any axis, it will aggregate every single thing and give you a single value. But if you specify an axis, it will now aggregate it based on the axis that you've indicated. All right. I hope that is very clear. So that's actually it for aggregation function. We have other like median, standard deviation, variance. So depending on what you want to do, there are other functions that we have in aggregation, in aggregating arrays, right? Or in aggregation basically. So that's actually it. We are done with today. So this the other thing we have here is basically just some concepts that we've talked about. We've talked about broadcasting already, right? I've explained it to you. So you can just look at this and use what we explained yesterday to understand it. right? But for this particular section, so what we have here, right? I'm just going to quickly go over it. We are basically introducing something new in NumPy. It is called random module. All right, let me quickly. So that is going to be the last thing we're going to talk about for today. Random. So random module in NumPy is used to generate random numbers. All right. So to do that, you have to basically just use np.random. Remember, I said if you want to see all the attributes and methods of a particular object, what function are you going to use? If you want to see all the attributes and methods of a particular object, what function are you going to use? Exactly. So it's from this interaction that I get to know my most active students. And all these things play a role in this program. So if you are just dormant there, you're actually doing yourself, all right? So I want everybody to be interacting because I'm seeing everybody's name as you are responding and all of that, right? So because if it comes to a point where I need to refer some of you for something, the person I will refer is obviously the person that I see often, like the person that is very active and all of that. So please try as much as you can to always interact with the class. This is a live class, so it's not meant to just be me. It's meant to be an interaction between the student and the tutor. All right. So exactly, we got that. It is the dir function. So I can come here and say dir np. All right. I come and say dir np. I'm going to get every single thing that is under np. So if I scroll down, I'm going to see a particular mode called random. You can see it here highlighted, right? So random is basically it is a module. A module is like if you go to a library now, like you go to a book library, physical library, just imagine NumPy as the library. Like you just enter the library. That is the main library, right? Imagine it as NumPy. Now imagine inside the library, you now have sections, different sub-libraries of different things. Maybe this section is for fiction books. This section is for English book. This section is for mathematics book. So now when it comes to NumPy, we also have different part of NumPy that you can use to do different things as well. So this random is like a sub library inside NumPy. So you can use it to do. It's not a function or an attribute. It's like a sub library, and we call it module, right? So it is used to generate random numbers. So if I come here and I say np.random and I use that dir on random too, I can come here and say np.random and I run it. You can see that the random has its own set of attributes and functions. Can you see? It has its own set of attributes and functions. So you can use np.random to do a lot of things, right? But I'm just going to show you how you can use it to generate random numbers. All right, so that is it for that. So to generate random numbers, generating random numbers with np.random module. All right, so I have to print this out. So I'll add a new cell here. Now you can see in this particular np.random functions, we have random. We have random here. So we have np.random. So you can see that we're now like using two dots So basically, we are referencing a particular function that is inside a particular section of NumPy. I hope you are following. Just like going to the library, and when we enter the library, we now went to a particular section for data science books. And that data science books, we now went to a particular section for a particular book under data science, right? So you are now retrieving a function inside a part of the library, not inside the library itself. So we are not accessing it directly from NumPy, like np.sum or np.add. It's now np.random.random. All right. So in this case, you can just use a function, right? So you have to put your bracket. You can put your shift and tab, and it will give you the documentation, right? What it does is that it returns random floats in the half open interval, blah, 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 and all of this. So if I come here, the parameter I have to pass in here is a size, right? I have to pass a size. So in this case, I'll pass 3 and 2 and run it. So this is what it's going to give me. It's going to generate random numbers between 0 and 1 of shape 3 and 2. That's what it does, all right? So it's just like your np.range, a range, or your np.linspace. For this one, it generates random numbers. So there are a lot of things you can use it for. So we have, so these are the ones we have here illustrated here. We have np.random.rand, all right? We have np.random.randn. So this n here means something. It means normal distribution. So it's a concept in statistics. We have np.random.randint, rand integer. All right. So this particular particular function is similar to the one we've looked at, which is a range. Right, but I'll show you the difference. The difference is that this the numbers that are generated here are actually random. They are actually random. That is why we have it under the random module. So if I come here and say np.random.rand int, and I come here and say between 1 and 20, all right? I want to generate 7 random numbers between 1 and 20. I'll run this. So you can see that it generated random numbers for us. 7 of them between 1 and 10 and 1 and 7. Sorry, 1 and 20, right? So you can see the different functions you can use in NumPy for a lot of things. So you have a lot of things to know. I don't expect you to know every single thing, but just have an idea on how to do it. So the ones you cannot remember, you can just come here and just do shift and tab, right? And it will give you an explanation of that particular function. You can see here, it returns random integers from this to this and all of that. It will even give you examples. And so this is basically what the random module does. All right. So we have 4 of them here. We have np.random.rand. We have np.random.randn. We have np.random.randint. And we also have np.random.random. All right. So yeah. So that's it. You can as well explore more on this particular random module. All right. You can explore more. And in the subsequent classes, we'll be referencing all these things that we'll be talking about. So yeah, that's it for today's class. We've come to the end of today's class. So what have we done so far? We looked at array manipulation, basically. We looked at reshaping arrays. We looked at flattening of arrays. We looked at transposing arrays. We looked at concatenating or joining arrays. We looked at splitting arrays. And we also looked at aggregation functions. Looked at different kinds of aggregation functions, the sum, mean, and all of that. And we looked at how we can aggregate based on an axis, right? If you want to aggregate according to the row, you specify it. If you want to aggregate according to the column, you specify it. We also looked at the random module. I introduced it to a random, including numbers, use random operations, all right? So we're going to call it a day here, and I'm going to be taking questions. So if you have questions pertaining to what we did today, please just indicate. I'll be taking questions now. All right. Okay.
Okay. Good evening, sir. Hello. Can I speak?
Hello. Hello, sir.
All right. Yeah, Ozema, sorry, please go ahead and ask your question.
Okay, good evening, sir. Thank you so much for the class. Please, I want to quickly on the reshaping of array, the NP dot reshape. Class was going on. I did something here and I noticed it showed me error. It was showing object is not callable. Then I tried to figure it out and I noticed that it was due to the comma there. So I want to ask, is it compulsory that the comma must be there?
Which comma?
The NP dot
Yeah.
reshape. Then if you
Okay.
are
Yeah,
calling the
yeah,
array,
yeah.
array,
Yes. Yeah, it should. Hello.
okay. Hello, sir, I can hear you.
I don't know if
Our
I'm getting
network is
your
bad.
question, but do you mean the reshape, the shape that you want to change it to, or what exactly?
Yes. I don't know if I can type it, if you can see it on the group. Let me see.
This kind of questions is better you add a screenshot to it. So I think it's better you just ask that in the Q&A with a screenshot so I can better understand um, the question and give you appropriate answer
All right,
because I don't think I get exactly what you're saying.
no problem, sir.
All right, patience, please go ahead and ask your question. Patience, you're on mute. Please go ahead and
Good
mute
evening, sir.
yourself and ask your question. Yeah, good evening.
Yeah, good evening, sir. When
Yeah,
we were
good
talking
evening.
about array manipulation, when we were talking about array manipulations, you talked about reshaping arrays, and two method of making use of that reshaping is NP
Yeah.
rearrange and NP resize. But why during the example you never mentioned of NP rearrange? You were still talking about NP reshape. Are they supposed to be the same thing?
Which other one are you talking about?
NP reshape and NP rearrange, are they the same thing?
Rearrange. Did I mention rearrange?
Yes, you said two method of doing reshaping of arrays. The first one is NP rearrange and NP resize. So while doing the examples, you never mentioned of make mention of rearrange. We're talking of
This,
reshaping and resizing only.
can you see my screen? Can you see my
Yes,
screen?
sir.
These are the
Yes, I
two
can.
I mentioned, np.reshape and np.resize. I didn't mention
Okay.
rearrange. So which one are you talking about?
Okay. Okay, sir. Okay, sir. I can now get it. Thanks.
All
I
right,
get it now, sir. I get it.
all right. Okay, I'll take the last person. Nicholas Ben, please ask your question. Please unmute yourself and ask your question, Nicholas. Nicholas.
Hello, can I ask if
All right,
if
yeah, go
can
ahead,
you?
Ismaila.
Okay, my question is, while you were running during the class, I think you used a shortcut to change your entire code into comments. I want to know the code.
Yeah, someone should answer that in the chat for him because we talked about that initially. Someone should just give an answer to that in the comment in the live chat. All right, so I think we are done with that. We are done with questions for today. So Ismaila, just to answer your question, you use control forward slash. I said this in the initial phase of this program. So mentioned it several times. So it's control slash. I don't know if you're just joining the program, but if you use your control slash, it automatically comments your code for you, or you put hash at the beginning of your comments, right? Or you do it manually, or you use control slash. Either way, you get your code to be commented. So yeah, that is it for today. But we have one more person. So Shoei, your hands is up. Please quickly ask your question, and then we call it a day. Um, okay, so I think we'll just have to take any other question in the Q&A. Any other question, please let it be dropped in the Q&A group, and I'll respond to them. So we have to leave now. We've actually spent more than we ought to. So thank you very much for your time and for your attention. Kindly highlight what you've learned in today's class in the live chat. I'll go through them and react to every one of them. Yeah, thank you very much, and enjoy the rest of your day. Good night.